What are some famous scientific theories that was later debunked? Story 1. Cold fusion, the discovery that was too good and too fast to be true. On March 23, 1989, electrochemists Stanley Pons and Martin Fleischmann held a press conference at the University of Utah to announce that they had achieved nuclear fusion at room temperature in a simple tabletop apparatus involving palladium electrodes immersed in heavy water. The claim was extraordinary. Nuclear fusion, the process that powers the sun, requiring temperatures of tens of millions of degrees Celsius, had apparently been achieved at room temperature, producing more energy than was put into the system. The implications were staggering. Unlimited clean energy from seawater. The end of fossil fuels, one of the most significant discoveries in the history of science. The announcement was made before the results had been peer-reviewed or independently replicated. Within weeks, laboratories around the world were attempting to reproduce the Fleischmann-Pons experiment. The results were almost universally negative. The excess heat that the original experimenters had reported could not be reliably reproduced. The nuclear products, neutrons and tritium, that should have accompanied a genuine fusion reaction were either absent or present at levels far below what the claimed energy output would require. The physics community was largely unable to explain the original results through conventional nuclear processes. The cold fusion frenzy collapsed within months. Pons and Fleischmann's careers were severely damaged. They subsequently moved their research to Europe, away from the intense scrutiny of the American scientific community. The episode became a textbook case in the sociology of science, of what happens when extraordinary claims are announced through press conference rather than peer review, when the desire to have made a world-changing discovery outpaces the rigor of the experimental verification. Cold fusion research has continued in small communities on the margins of mainstream science under the rebranded name of low-energy nuclear reactions. Occasional reports of anomalous heat continue to appear. The mainstream scientific consensus remains that the original Fleischmann-Pons results were likely the product of experimental error, and that the physics of nuclear fusion at room temperature is not consistent with what is known about the strong nuclear force. The dream was real. The experiment was not. Story 2. Phrenology was, in the early 19th century, a serious scientific enterprise. Its founder, Franz Joseph Gall, was a credentialed anatomist with genuine contributions to the understanding of brain structure, who proposed in 1796 that the brain was the organ of the mind, that different mental faculties were located in different parts of the brain, and that the development of these faculties would cause the corresponding brain region to enlarge, pushing the skull outward in measurable ways. Johann Spurzheim systematized and popularized Gall's ideas into phrenology, the reading of mental character from the contours of the skull, which became one of the most widely practiced and publicly embraced sciences of the 19th century. The appeal was obvious. Phrenology promised a simple, observable, measurable way to assess the mental and moral character of individuals. Practitioners built careers identifying criminals by their skull shapes, advising employers on the suitability of job candidates, and counseling parents on the aptitudes of their children. Phrenological charts mapping the mental faculties to specific cranial regions were sold widely and displayed in public establishments. The science had practitioners across Europe and America, institutional organizations, journals, and a substantial public following. The problem was the foundational premise. The skull does not reliably reflect the shape of the underlying brain. The brain does not enlarge specific regions in response to the exercise of specific faculties in ways that would be measurable at the cranial surface. The mental faculties that phrenology proposed to measure did not correspond to discrete, localized brain functions. The readings that phrenologists produced were not replicable across different practitioners examining the same subject. Modern neuroscience has confirmed that some of Gall's underlying intuitions were correct. The brain is the organ of the mind, and different functions are associated with different brain regions. But the localizations are nothing like what phrenology proposed. The skull tells you almost nothing about the underlying brain structure. and the specific claims of character reading from cranial contours are entirely without foundation. Phrenology was used to justify racism and eugenics. Its pseudo-scientific legacy is one of the most destructive in the history of science. Story 3. The blank slate. The theory that genes don't matter and experience is everything. The blank slate, tabula rasa in the Latin of the philosophers, is the proposition that the human mind at birth is an empty receptacle, containing no innate content waiting to be filled by experience. John Locke gave it its most influential formulation in his 1689 essay concerning human understanding, arguing against the Cartesian doctrine of innate ideas and proposing instead that all knowledge derives from sensation and reflection. The tabula rasa was not merely a philosophical position. It became, in the 20th century, the foundational assumption of large portions of psychology, education theory, sociology, and political philosophy. The social sciences of the mid-20th century embraced blank slate assumptions with an enthusiasm that was partly empirical and partly political. If human nature is infinitely malleable, if all differences between individuals and groups reflect environmental conditioning rather than inherited characteristics, then the project of social improvement through environmental intervention becomes both possible and sufficient. Behaviorism, the dominant psychology of the mid-20th century, explicitly excluded innate mental content from its domain of study. The standard social science model, as Steven Pinker later named it, treated culture as the primary determinant of human behavior and treated biology as largely irrelevant. The collapse of the blank slate as a scientific position, though not as a cultural assumption, came from multiple directions simultaneously. Behavioral genetics demonstrated that virtually every measured psychological characteristic shows significant heritability, that identical twins raised apart are more similar to each other than fraternal twins raised together. Evolutionary psychology provided theoretical frameworks for understanding which psychological features would be expected to be universal across cultures and which would vary. Cross-cultural research confirmed the existence of universal human behavioral patterns that could not be explained by shared cultural conditioning. The blank slate is not entirely wrong. Experience matters enormously, and the interaction between genes and environment is complex. But the strong version of the theory, which held that genes are irrelevant to psychological characteristics, did not survive contact with the evidence. Story 4. Luminiferous aether. The invisible medium that had to exist and didn't for most of the 19th century. The aether was not a fringe idea. It was the physically necessary medium through which light waves propagated, required by the same logic that requires water for water waves and air for sound waves. Waves, by definition, are disturbances in a medium. Light was a wave, demonstrated conclusively by Young's interference experiment in 1801, and confirmed by Maxwell's electromagnetic theory in 1865. Therefore, light propagated through a medium. The medium was called the luminiferous aether. Its properties were constrained by what was known about light. It had to be extraordinarily rigid, more rigid than steel, to transmit waves at the speed of light, yet offer no resistance to the motion of planets through it. It had to fill all of space. It had to be undetectable by any direct means. The properties required of the aether were, even before the decisive experimental test, sufficiently contradictory to trouble physicists. The Michelson-Morley experiment of 1887 was designed to detect the aether by measuring the effect of Earth's motion through it on the speed of light in different directions. If the aether existed and Earth moved through it, light traveling in the direction of Earth's motion should show a slightly different speed than light traveling perpendicular to it. The experiment detected no such difference. The null result was one of the most consequential experimental failures in physics history. The attempts to save the aether, Lorentz and Fitzgerald independently proposed that objects contract in the direction of motion through the aether by exactly the amount required to explain the null result, produced mathematics that worked but required a physical mechanism that no one could explain. Einstein's special relativity in 1905 simply abandoned the aether. The theory required only the constancy of the speed of light in all inertial reference frames, dispensed with the medium, and produced the same mathematics as the Lorentz transformation without requiring an undetectable substance to exist. The aether was the most physically reasonable theory that turned out to be completely wrong. Story 5. Einstein's static universe, the blunder the greatest physicist called his greatest blunder in 1917. Albert Einstein applied his newly completed general theory of relativity to the universe as a whole, the first attempt to use a physical theory to describe the cosmos at its largest scale. The result was a problem. His equations, applied to a universe filled with matter, predicted that the universe could not be static. Gravity would cause it to collapse. Einstein found this conclusion unacceptable. The prevailing scientific and philosophical assumption of the time was that the universe was eternal and unchanging, and he introduced a modification to his equations, a cosmological constant, represented by the Greek letter lambda, that represented a repulsive force operating on large scales to counteract gravitational attraction and hold the universe in a static equilibrium. The static universe model had problems from the beginning that Einstein himself acknowledged. The equilibrium it described was unstable, like a pencil balanced on its point. Any slight perturbation would cause the universe to either collapse or expand. The cosmological constant had no physical justification beyond the desire to produce a static solution. Einstein had added a term to his equation specifically to get the answer he wanted, which is not standard scientific practice. The observational demolition came from Edwin Hubble. In 1929, Hubble published his analysis of the recession velocities of galaxies as measured by the redshift of their spectra. Distant galaxies were receding from us, and the further away they were, the faster they were receding. The universe was expanding. When the expansion was extrapolated backward in time, it implied that the universe had begun in a hot, dense state, what Georges Lemaitre had proposed as the primeval atom, and what Fred Hoyle, attempting to mock the idea, called the Big Bang. Einstein reportedly called the introduction of the cosmological constant his greatest blunder. Ironically, the discovery of the accelerating expansion of the universe in 1998 required reintroducing the cosmological constant as dark energy. He was wrong, and then he was partly right again for entirely different reasons. Story 6. The Martian Canals, the civilization that was an optical illusion. Giovanni Schiaparelli, the director of the Milan Observatory, observed Mars during its 1877 opposition, when the planet was unusually close to Earth, and recorded a network of linear features crossing the planet's surface. He called them canali, which in Italian means channels, a word that carries no implication of artificial construction. The word was translated into English as canals, a word that carries precisely that implication, and the resulting confusion became one of the most consequential translation errors in the history of astronomy. Percival Lowell, a wealthy American businessman and amateur astronomer, read about Schiaparelli's canali and became convinced that they were the engineering works of a dying Martian civilization. He built an observatory in Flagstaff, Arizona, specifically to study Mars, and from 1894 onward produced detailed maps of the Martian Canal network, a system of hundreds of straight lines crossing the planet's surface that he interpreted as irrigation channels carrying water from the polar ice caps to the desert lowlands. He wrote 3 books about Martian civilization, became famous, and helped inspire the broader cultural conversation about life on other planets that shaped science fiction for the following century. The problem was that the canals were not visible to everyone who looked. Other astronomers examining Mars through equally powerful telescopes often saw nothing. Eugne Antoniadi, working with a superior telescope at the Meudon Observatory, found that what had appeared as straight lines at lower resolution resolved into irregular blotchy features at higher resolution. The human visual system, when presented with faint, ambiguous features at the limit of resolution, tends to impose linear structure, to connect dots into lines, in a way that creates apparent geometric patterns where none exist. The Mariner 4 spacecraft resolved the question definitively in 1965, returning images of a cratered canal-free Mars. Lowell's civilization was never there. The canals were what the human brain does when it wants to see something. Story 7. Phlogiston. The fire substance that explained everything, except what it was phlogiston theory, was the dominant explanation for combustion in chemistry for over a century. Proposed by Johann Joachim Becher in 1667 and developed by Georg Ernst Stahl into a systematic theory in the early 18th century, it proposed that all combustible materials contained a substance called phlogiston that was released during burning. When wood burned, it released phlogiston into the air. When air became saturated with phlogiston, combustion ceased. The theory explained why fires in enclosed spaces eventually extinguish, why charcoal, which burned almost completely, seemed to be nearly pure phlogiston, and why metals that rusted seemed to lose something in the process. The theory's explanatory power was genuine within its domain, and it organized a great deal of chemical knowledge productively. Robert Boyle, Joseph Priestley, and many other significant chemists worked within its framework. Priestley, who isolated oxygen in 1774, described it as dephlogisticated air that had been stripped of phlogiston and could therefore support more combustion. He never recognized oxygen as a new substance. He understood it as air from which phlogiston was absent. Antoine Lavoisier was the chemist who demolished phlogiston theory through systematic quantitative experimentation. He demonstrated, through careful weighing of reactants and products, that combustion involved the combination of the burning substance with a component of air rather than the release of a substance from the burning material. When metals burned, they gained weight, the opposite of what phlogiston theory predicted if burning involved releasing phlogiston. The component of air that combined with the burning substance was what Lavoisier named oxygen. The transition from phlogiston to oxygen theory is one of the most studied episodes in the history and philosophy of science, a case where a theory that successfully organized existing knowledge was replaced by a theory that revealed why the knowledge had that organization. Story 8. The expanding Earth hypothesis proposed that the continents had originally formed a single landmass covering the entire surface of a smaller Earth, and that as the Earth expanded over geological time, the continents were pushed apart by new ocean floor forming in the gaps. The hypothesis addressed one of the central puzzles of early 20th century geology, the remarkable fit of the continental coastlines, particularly the apparent correspondence between the east coast of South America and the west coast of Africa, and the evidence that similar geological formations and fossil species appeared on continents now separated by thousands of miles of ocean. Alfred Wegener proposed continental drift in 1912 as a different solution to the same puzzle, that the continents had moved relative to each other without the Earth changing in size. Wegener's theory was received with considerable skepticism in his lifetime, partly because he could not propose a credible mechanism for moving continents through oceanic crust. The expanding Earth hypothesis, proposed by various researchers including Samuel Warren Carey, offered an alternative explanation for continental drift that did not require continents to plow through oceanic crust. The resolution came not from expanding Earth, but from plate tectonics, the theory, developed through the 1950s and 60s, that the Earth's surface is composed of rigid plates that move relative to each other, with new oceanic crust being created at mid-ocean ridges and old crust being subducted into the mantle at convergent boundaries. Plate tectonics explained the evidence for continental movement without requiring Earth expansion. Seismic evidence confirmed the plate boundaries. Paleomagnetic evidence confirmed the seafloor spreading that created new crust. Measurements of the Earth's size using modern satellite geodesy have confirmed that the Earth is not expanding in any geologically significant way. The continents moved. The Earth stayed the same size. Story 9. Planet Vulcan, the world that was predicted and never found. Urbain Le Verrier was one of the greatest mathematical astronomers of the 19th century. In 1846, his calculations of the perturbations in the orbit of Uranus led him to predict the existence of an undiscovered planet, Neptune, at a specific location in the sky. When observers pointed telescopes at that location, they found Neptune within 1 degree of Leverrier's prediction. It was one of the greatest triumphs of Newtonian mechanics and predictive astronomy. Armed with this success, Leverrier turned his attention to an anomaly in the orbit of Mercury. Mercury's perihelion, the point in its orbit closest to the Sun, precesses at a rate that Newton's mechanics could not fully explain. Accounting for the gravitational influence of all known planets, a residual precession remained unaccounted for, 43 arcseconds per century. By the same reasoning that had led him to Neptune, Leverrier concluded that the anomalous precession must be caused by an undiscovered planet orbiting the Sun inside Mercury's orbit. He named the hypothetical planet Vulcan. Leverrier's prediction generated a minor astronomical gold rush. Several observers reported transits of a small body across the face of the Sun, observations that were enthusiastically but prematurely identified as sightings of Vulcan. Edmond Modeste Lescarbot, a French amateur astronomer, reported observing a Vulcan transit in 1859 with enough detail to convince Leverrier, who announced the discovery to the French Academy of Sciences. Subsequent observations failed to confirm the transit, and repeated searches of the expected orbital regions found nothing. Vulcan's non-existence was explained, and Mercury's orbital anomaly resolved by Einstein's general theory of relativity in 1915. The precession of Mercury's perihelion is a consequence of the curvature of spacetime near the Sun. It is not caused by a missing planet, but by the geometry of space itself. It was one of the first experimental confirmations of general relativity. No Vulcan exists. No Vulcan needs to exist. Story 10. Spontaneous generation, the idea that living organisms can arise directly from non-living matter, was not an obvious mistake. It appeared to be supported by direct observation. Maggots appeared on rotting meat. Mice appeared in stored grain. Eels appeared in river mud after floods. The organisms seemed to emerge from the non-living material rather than from other organisms. Aristotle described the principle systematically, and it remained the dominant account of the origin of lower animals for 2,000 years. The experimental challenges to spontaneous generation accumulated gradually across 3 centuries. Francesco Redi demonstrated in 1668 that maggots did not appear on meat that was sealed against flies. Jan Swammerdam's microscopic studies revealed the life cycles of insects that apparently generated spontaneously, showing the adult organism, egg, and larva stages. Lazzaro Spallanzani demonstrated in the 18th century that broth that had been sealed and boiled did not produce microbial growth, though supporters of spontaneous generation argued that boiling destroyed the vital principle that allowed spontaneous generation to occur, and that his sealed flasks excluded the air necessary for it. Louis Pasteur resolved the debate definitively with his famous swan neck flask experiment in 1859. He prepared broth in flasks with long curved necks that allowed air to pass into the flask but prevented airborne particles from reaching the broth. The broth remained clear. When he broke the necks, allowing particles to fall directly into the broth, it became turbid with microbial growth within days. Life came from life. Biogenesis, the principle that living things come only from other living things, was established. The origin of life from non-living chemistry remains an active research question, but the spontaneous generation of complex organisms from non-living matter under ordinary conditions is not happening. Story 11. Planet Vulcan, when the discovery was a parasite in the lens the photograph, arrived from the Zurich Observatory on a Tuesday morning in November 1857, and Professor Heinrich Adelmann could not stop staring at it. There, captured in the daguerreotype with perfect geometric precision, was the transit of an undiscovered planet crossing the solar disk, a planet orbiting between Mercury and the Sun, precisely where Leverrier's calculations said Vulcan must exist. Adelmann sent the image to 3 separate observatories before nightfall. By Friday, his name was in every newspaper in Europe. He spent the next 18 months giving lectures. Governments sent him letters. The Royal Astronomical Society awarded him their gold medal. He had found the missing planet. He had confirmed Newton. He had done what only Leverrier had previously managed, and he had done it with a photographic plate instead of equations. The doubt arrived slowly. Other observatories attempted to photograph the same transit at the same time and found nothing. Adelman examined his original plate under magnification and noticed something he had initially dismissed as a smear in the emulsion. Under higher magnification still, it was moving. Not in the hours between exposures, but within a single exposure. A slow, deliberate crawl across the solar disk that no planet could produce. The organism was isolated from the plate's gelatin emulsion layer by a biologist at the University of Basel who had never heard of Vulcan and who classified it without ceremony as a previously undescribed species of extremophilic microorganism capable of surviving and reproducing on photographic media. It was approaching Earth from the direction of the inner solar system and had been for some years. The planet Vulcan does not exist. The microorganism that convinced everyone it did has been in the water supply of 4 European capitals for 6 months. Nobody has noticed yet. Story 12. Martian Canals. The countdown nobody read in time. James Prentice made his first observation of the Martian canals on the night of October 14, 1895, through the 15-inch refractor telescope his father had built in the observatory attached to their Hampshire farmhouse. He was 23 years old, had read all of Percival Lowell's articles in the Atlantic Monthly, and had devoted the previous 2 summers to learning to observe. He expected to see the canals. He did not expect to see them change. He observed the same canal network on October 15 and found it different. A junction that had been clearly bifurcated on the previous night had merged into a single line. He checked his notes. He checked his eyepiece. He checked the atmospheric seeing. He observed again on October 16 and found it different again. Over the following 3 weeks, he filled 6 notebooks with observations and covered a wall of the observatory with a grid of sketches, and the pattern became unmistakable. The canal network was not a static feature of the Martian surface. It was a dynamic system, and its configuration was changing in a way that was too structured to be random. He brought his notebooks to Professor Wayland at Southampton, who was dismissive. He wrote to Lowell, who did not reply. He wrote to the Royal Astronomical Society, whose secretary thanked him for his communication and noted that amateur observations were not generally considered reliable enough to challenge established telescopic records. He published his grid of 69 observations in a small journal in 1897. The editor cut his conclusion. He died in 1943, having never returned to the telescope. The grid, examined from the end rather than the beginning, resolves into a sequence. The sequence is an integer countdown from 69 to 0. It reached 0 on the night of October 15, 1895, the night before Prentice made his first observation. Whatever it was counting down to, it already happened. We are what came after. Story 13. The Open Polar Sea. What the Victorian explorers found at the end of the ice. The theory of the open polar sea was, by the standards of its time, not unreasonable. The Gulf Stream carried warm water northward into the Arctic. Some navigators reported that the ice grew thinner as they pushed further north. The observation that the sun shone continuously during Arctic summer seemed to support the idea that the polar region, if reached, might be warmer than the approaches suggested. Elisha Kent Kane, who led 2 American Arctic expeditions in the 1850s, reported what he believed was evidence of open water beyond the ice pack. The theory had adherents in the learned societies of Britain and America and provided motivation for some of the most ambitious and deadly expeditions of the 19th century. In the summer of 1880, the schooner Perseverance, under Captain Aloysius Rourke, became the first vessel to break through the polar ice pack into open water north of 88 degrees latitude. What they found was not what any theory had predicted. The water was warm, warmer than the Gulf Stream by 20 degrees Fahrenheit. It was also luminescent, not in the way that bioluminescent plankton produces faint surface glow, but in the way that something very large and very active produces illumination from depth. The light pulsed with a rhythm that the ship's doctor, Edmund Haverstock, described in his journal as cardiovascular. Rourke anchored for 9 days. None of the crew went into the water. None of them discussed, either in their journals or in subsequent interviews, what they had seen below the surface. When the Perseverance returned to Aberdeen, Rourke filed a navigational report confirming open polar water and listing no significant observations of note. Haverstock's journal was not included in the official expedition record. It came to light in a Dundee estate auction in 1951, purchased by a private collector who donated it to no institution. His family still has it. Story 14. Counter-Earth. The broadcast from the other side of the sun, the Pioneer 10 spacecraft, was launched in March 1972 and was the first human-made object designed to leave the solar system. Before its solar escape trajectory carried it beyond Jupiter, it was routed to conduct a gravitational assist maneuver that brought it, briefly, to a position behind the sun relative to Earth, a position no previous spacecraft had occupied, and from which the hypothetical counter-Earth of the ancient philosopher Philaeus could, in principle, have been observed. The anomaly in the Pioneer 10 data archive was identified in 1977 by Dr. Constance Verlhack at JPL during a routine review of transmission logs. A 14-minute segment of compressed imaging data from April 1973 had been archived without processing under an administrative miscategorization. When Verlhack decompressed and displayed the images, she found a sequence of 847 frames showing a planetary body approximately Earth-sized at a distance consistent with the L2 Lagrange point of the Sun-Earth system, a position that counter-Earth theorists had proposed as the most likely location for a co-orbital body. Verlhack noted the images in her review report and flagged them for verification. The following morning, her access to the Pioneer 10 archive was suspended pending a security review. The review took 4 months. When her access was restored, the 14-minute segment had been reclassified. She was told the anomalous images were the result of a detector calibration error. She accepted this explanation for 11 years, until a colleague who had seen her review report mentioned that the images she had described sounded exactly like something he had heard about from someone at a different facility. That, in one image. Every person visible on the planetary surface was looking directly into the camera. Verlhack retired in 1991. She has not discussed the images publicly. This account is based on a letter she wrote to her daughter, which the daughter has shared. Story 15. Caloric Theory. The bottled heat that took from memory. Count Rumford's 1798 experiments on cannon boring at the Munich arsenal were the event that finally unraveled caloric theory. The demonstration that friction could produce an apparently unlimited amount of heat from a fixed amount of material, which made no sense if heat were a conserved fluid substance. But caloric theory died slowly because its mathematical framework was genuinely useful, and because no one proposed an alternative that explained everything caloric theory explained, while also explaining what it could not. In the Paris of 1831, a former student of the École Polytechnique named Sébastien Roux was working on exactly this alternative when he discovered something he had not been looking for. He was attempting to concentrate caloric fluid through a series of compression and expansion cycles to see if he could produce a sample more pure than any naturally occurring heat source. What he produced was not pure. It was something he described in his notebooks as inversely saturated, a fluid that, when applied to a surface, did not heat it, but extracted warmth from it in a way that exceeded what the room temperature differential would account for. He bottled it. He sold it initially to wealthy clients as a winter heating supplement. His customers reported that their houses became warm in the hours after application and cold again after a few days, requiring more of the fluid. They also reported, without connecting it to the product, that their memories of winter, of specific cold moments, cold places, cold childhood experiences, had become vague. Roux's own journals become sparse in the months after the discovery. His final entry, dated March 1833, is a single sentence. The fluid does not borrow heat from the room. The room is irrelevant. He died that April. The cause was listed as exposure. He was found inside his laboratory. Story 16. Rain follows the plow. The belief that broke the Great Plains rain follows the plow was not simply a popular saying. It was a seriously proposed climatological theory, advanced in the 1870s by Charles Dana Wilbur and supported by a number of scientists who observed, or believed they observed, a correlation between agricultural settlement and increased rainfall in the American Great Plains. The mechanism proposed was that cultivation of the soil released moisture that rose into the atmosphere and precipitated as rain, that trees planted as windbreaks altered local wind patterns, and that the increased ground temperature produced by plowed, dark soil generated convective currents that drew moist air inland. The theory provided scientific justification for the Homestead Acts, encouragement of settlement on the semi-arid plains, and helped persuade hundreds of thousands of farmers to invest their life savings in land that the previous assessment of explorers like Zebulon Pike had deemed the Great American Desert. In the wet years of the 1870s and 1880s, the theory appeared to be confirmed. Rainfall in Kansas and Nebraska seemed to increase with settlement. Crops grew. Towns were built. The land was platted into the grid of section lines that still marks the satellite view of the Great Plains. The farmers had done what the theory said would happen. They had made the rain follow the plow. The dry years demonstrated what had actually happened. The wet years of settlement had been a natural climatic cycle, not a product of farming. When the cycle ended, the rain did not follow the plow into the drought. What followed the plow, when the topsoil dried out and the winds came, was the Dust Bowl, a decade of catastrophic soil erosion and agricultural failure that drove hundreds of thousands of families off the land their parents had broken in the confidence that science had told them the rain would come. The theory was wrong. The people who believed it paid the price. Story 17. Galvanism. The electrical current that opened dead eyes and moved dead hands. Luigi Galvani's 1791 discovery that electrical stimulation could produce muscular contraction in dead frogs was one of the most dramatic experimental results in the history of science. The frog's legs kicked. The dead moved. The boundary between life and non-life appeared, for a moment, to be a boundary crossed by electrical current. Galvani interpreted this as evidence of animal electricity, a vital fluid that resided in living tissue and could be stimulated by external electricity. His nephew, Giovanni Aldini, took the principle to its theatrical extreme, demonstrating galvanic stimulation on human cadavers in public performances across Europe that caused dead men to appear to grimace, open their eyes, and raise their hands. The demonstrations were staged before audiences of hundreds and reported in newspapers across the continent. Mary Shelley attended one of these demonstrations as a child. She did not forget it. The medical student Edmund Hartwick acquired an unusually complete specimen in the autumn of 1818. A recently deceased anatomist, whose will had left his body to science and who had, with characteristic thoroughness, provided detailed notes on his own nervous system. Hartwick built a battery of 60 cells and connected it to the specimen through a system of electrodes more comprehensive than anything Aldini had used, targeting not individual muscles, but the network of spinal pathways he intended to drive as an integrated system. The first current was applied at 3 a.m. on a Thursday. The body sat up. This was not, Hartwick noted in his journal, the sudden convulsive jerk of galvanic stimulation. It was slow and purposive. The eyes opened. They tracked. The mouth moved without producing sound for approximately 40 minutes, while Hartwick documented everything he could think to document. Then, the current was severed by a failure in the battery circuit. The body lay down. Hartwick left the laboratory and never returned. He burned his journals the following morning. He became a clergyman. Story 18. The suffocation speed limit. The train that trapped its passengers in 1 second when the first steam-powered passenger railways opened in Britain in the early 1830s. The speed at which the locomotives traveled, between 20 and 40 miles per hour, was unprecedented in human experience. The fastest any human had previously moved was approximately 30 miles per hour on a galloping horse, and the medical establishment was not unanimous that faster speeds were safe for the human body. Among the concerns proposed by physicians of the period were that rapid passage through air would cause suffocation, that the visual impressions produced by high-speed travel would damage the eyes, and that the body's organs might be displaced by sustained acceleration. These concerns were largely dismissed by the engineers and the railway promoters, and the first decades of railway travel demonstrated that passengers survived speeds of 40, 50, and 60 miles per hour without physiological collapse. The suffocation theory was wrong. The travel was safe. The medical establishment moved on to other concerns. The driver of the 742 Leeds to Manchester Express on the morning of March 3, 1841, throttled past 60 miles per hour on the long downgrade outside Saddleworth, and did not notice for several miles that no steam was issuing from the safety valve. When he looked back at the passenger carriages, the windows were uniformly dark. When the train arrived in Manchester and the station staff opened the doors, they found every passenger in an identical posture, hands in their laps, heads forward, eyes open, and alive, in the sense that their hearts were beating and their lungs were moving air. But no passenger responded to voice or touch. The station doctor's report described them as conscious but unreachable, present in their bodies but not in the moment. They remained in this state for a variable period between 6 minutes and 4 years. The railway company settled all claims quietly and with generous terms. The speed limit on British railways was set at 55 miles per hour the following year by a parliamentary committee whose report did not explain why. Story 19. The Homunculus, the tiny man who whispered from the jar. Preformationism, the theory that organisms do not develop from undifferentiated material, but contain within them a fully performed miniature of the adult organism, had a visual representation that became one of the most famous images in the history of biology. The homunculus, the tiny human figure supposedly visible inside a spermatozoon when examined under the microscope. Nicholas Hartsoker drew the image in 1695, not as an observed fact, but as a representation of what he believed must be there, the performed human curled inside the sperm cell, waiting only to unfold. The microscopes of the period were not capable of seeing a homunculus. What Hartsoker and other preformationists were responding to was a conceptual problem. If organisms do not come preformed, how does the process of development produce a specific, complex organism from undifferentiated material? Epigenesis, the emergence of form from formless beginnings, seemed to require that something organized was not already present, which seemed to require a directing force whose nature was unclear. Preformationism solved the problem by asserting that the organization was already there, just very small. The microscope improved. The homunculus was not found. What Henrik Bowman found in the winter of 1763 in Leiden was something smaller and more specific, a single spermatozoon that, under his best lens, appeared to contain not a human form, but a legible script. The characters were not Latin, Greek, or Hebrew, and were unlike any writing system in the collection of the university library. They covered the entire inner surface of the cell. Bowman spent 3 months attempting to copy them accurately before his eyesight failed. His copies are in a box in the Leiden University archive under a catalog number assigned to uncategorized early modern manuscripts. The box has not been opened for research purposes since 1987. The whispers Bowman reported hearing from the direction of his microscope in the final weeks of his observations are mentioned in his diary, which is in the same box. Story 20. Telegony, the first husband's code that consumed the second family. Telegony was the belief, held with surprising tenacity in both popular and scientific culture through the 19th century, that a female organism could be permanently influenced by her first mate in ways that would manifest in the offspring of subsequent matings, that a thoroughbred mare that had produced a mixed breed foal with a zebra would, in subsequent matings with thoroughbred stallions, produce foals bearing zebra-like markings. Francis Galton set out to refute the theory experimentally by transfusing blood between rabbits of different colors and demonstrating that the blood transfusions had no effect on the coat colors of subsequent offspring. Darwin corresponded about telegony. August Weismann's germplasm theory, which established that hereditary material was carried in the germline and was not affected by somatic experiences, provided the theoretical framework that made telegony impossible. The theory was wrong. It is comprehensively wrong. There is no mechanism by which a previous mate can influence the genetic characteristics of offspring produced with a subsequent mate in mammals. Charlotte Alderton was delivered of a son on the morning of February 7, 1887, 18 months after the death of her first husband, Edward, and 7 months after her marriage to William. The son was named after William. He had William's family's coloring and something of William's build. He also had Edward's eyes, which was odd, because Edward had been distinctly dark-eyed, and both Charlotte and William were blue-eyed. And he had a small mark on his left forearm, in exactly the position and shape of a burn scar Edward had acquired in a workshop accident at 19. The family physician, when consulted, mentioned telegony as a possibility and was dismissed. The boy grew up unremarkably in most respects. He never burned his left arm. The scar was there from birth. He could describe the workshop and the day of the accident in detail. He could not explain how he knew. Story 21. The vegetable lamb. The plant that cried and ate the people who came the vegetable lamb of Tartary, Agnus Scythicus, was one of the most persistent botanical myths in European natural history. Described in texts from the 14th century onward as a plant that produced a fruit in the shape of a lamb, connected to the plant by a cord at the lamb's navel, which the lamb ate by grazing the surrounding vegetation. When the vegetation was exhausted, both plant and lamb fruit died. The myth was taken seriously by John Mandeville, whose travels described it as a first-hand observation. Francis Bacon mentioned it. The Royal Society received specimens and examined them. The specimens were invariably fern rhizomes carved and trimmed to produce a vaguely ovine silhouette, a cottage industry in Central Asia supplying the European market for curiosities. The vegetable lamb does not exist. The myth was explained, eventually, as a misunderstanding of the cotton plant, whose bolls of fibrae superficially resemble white fleece, and as the product of enthusiastic elaboration by travelers whose accounts were too distant to verify. The collector Jacob Branius, who published the most thorough debunking of the vegetable lamb in 1725, had purchased a particularly fine specimen from a Cossack trader in 1719. He examined it closely enough to determine it was a fern rhizome, put it on a shelf in his study, and forgot about it for 2 years. In the winter of 1721, he was awakened on 3 successive nights by a sound from his study that he described as a lamb crying. He found nothing wrong with the specimen on each occasion. On the 4th night, he did not go to the study. He moved the specimen to his garden shed the following morning. The crying did not follow it. It stayed in the study. He sold his house in 1722. The buyer's correspondence from their first winter there is in the Gdansk archives. The last letter is from March. It is about the sound. Story 22. The toothworm, the parasite that escaped into the water. The toothworm is one of the most enduring myths in the history of medicine. The idea that toothache was caused by a worm eating the tooth from within appears in Sumerian texts from 5,000 years ago, in ancient Egyptian medical papyri, in medieval Islamic medical texts, and in the professional literature of European dentistry through the 18th century. The myth persisted despite the fact that no such worm was ever actually extracted from a tooth. When dentists claimed to extract toothworms, they were extracting the dental nerve, which they could show to patients as a wriggling thread of tissue. The myth provided a satisfying explanation for a genuinely puzzling phenomenon: why teeth hurt, and why the extraction of a specific structure from inside the tooth could relieve the pain. The nerve as toothworm made a useful conceptual bridge between the myth and the anatomical reality. What Heinrich Krauss extracted from the molar of the merchant Conrad Esser on the afternoon of April 3, 1703, in the Augsburg barbershop where Krauss practiced dentistry, was not the dental nerve. It was moving when it came out. It continued moving in the dish of water Krauss placed it in for the remainder of the afternoon. He left it there when he closed the shop. In the morning it was gone, and the water was turbid. By the following week, 7 of the 8 families on Krauss's street were complaining of toothache. By the following month, 23. Krauss moved to Munich in 1704. He moved to Vienna in 1706. In each city, he stayed approximately 2 years. In each city, within 6 months of his arrival, the dental complaints of the surrounding streets increased significantly. His practice records from the Munich period show a notable concentration of patients presenting with identical symptoms and no visible decay. He retired in 1711. He never published. Story 23. The Steady-State Universe, Creation Without Beginning or End. The steady-state theory was proposed in 1948 by Fred Hoyle, Thomas Gold, and Hermann Bondi as an alternative to the Big Bang cosmology that the expansion of the universe seemed to require. If the universe is expanding and was therefore denser in the past, extrapolating backward leads to a beginning, a state of infinite density at a finite time in the past. Hoyle found this philosophically unsatisfying. A universe with a beginning required an explanation of what came before the beginning and what caused it. His steady-state model proposed that the universe had no beginning and no end. It had always existed and would always exist in approximately its current form, with new matter being continuously created from nothing at a rate sufficient to maintain constant average density as the universe expanded. The theory was scientifically serious. It made specific predictions about what observations should reveal about the universe at large distances, which, because of light travel time, correspond to the universe at early times. If the universe is the same at all times, observations of the distant universe should show similar properties to observations of the nearby universe. If the Big Bang model is correct, the distant universe should look different, denser, younger, populated by different types of objects. The discovery of the cosmic microwave background radiation in 1965 effectively ended the steady-state model. The CMB is the thermal afterglow of the hot early universe, and its existence is predicted by Big Bang cosmology and inexplicable within steady state. Radio astronomy surveys also showed that the population of radio galaxies changed with distance, with cosmic time, in ways inconsistent with a universe that looked the same at all epochs. Hoyle remained a steady-state advocate for the rest of his career. He was also, as it happened, the person who coined the term Big Bang as a dismissive description of the rival theory. The name stuck. Story 24. The intralunar atmosphere. The heavy gases hiding in the moon's craters. The moon's lack of a significant atmosphere is established beyond any reasonable scientific doubt. Its surface gravity, approximately 1/6 of Earth's, is insufficient to retain gases against the solar wind and thermal escape. The lighter gases escape almost immediately. Even heavier gases escape on geological timescales. The Apollo missions, whose astronauts worked in vacuum suits on a surface with an atmospheric pressure approximately 1/trillionth of Earth's, confirmed that the moon is about as close to a perfect vacuum as any large body in the solar system. The intralunar atmosphere hypothesis that heavy gases might concentrate in the deepest craters and canyons, particularly those near the lunar poles that remain permanently shadowed, has a grain of physical plausibility. The permanently shadowed craters at the lunar poles are extraordinarily cold, cold enough that volatile compounds including water ice and other materials can persist for billions of years. The Okra spacecraft confirmed the presence of water ice in a lunar polar crater in 2009. Heavier gases might, in principle, be somewhat more persistent in these extreme cold traps than in sunlit regions, but the relevant quantities are so small as to be physiologically irrelevant. The moon has no atmospheric reservoir to replenish gases that escape, and no geological processes producing gas in the quantities required to maintain any detectable concentration. The craters are cold traps for volatiles, not reservoirs of breathable atmosphere. The persistent fantasy of lunar cave systems containing trapped heavy gas atmospheres inhabitable without suits is the kind of wishful thinking that the physics consistently refuses to support. The moon's craters contain ice. They do not contain air. The distinction matters enormously to anyone planning to visit. Story 25. The Neptunian Sun Mirror, the diamond planet reflecting light to Earth. Neptune, the outermost planet of the solar system, at approximately 30 astronomical units from the Sun, receives sunlight approximately 900 times weaker than Earth does. Its atmosphere is the most active in the solar system. Despite this faint illumination, winds at Neptune exceed 2,000 kilometers per hour, the fastest of any planet. The source of the energy driving this atmospheric activity is partially from solar energy and partially from internal heat left over from the planet's formation. But the internal heat source is not fully understood. The diamond interior hypothesis is real, mainstream planetary science. At the pressures existing in Neptune's interior, carbon is predicted to exist in a crystalline structure, diamond, at depths where temperatures and pressures are extreme enough to permit the synthesis and stability of large diamond crystals. The Oceans of Diamond model of Neptune's interior is a legitimate scientific proposal with theoretical support. The idea that Neptune might contain very large diamond structures in its interior is not fringe. The hyper-reflective outer shell hypothesis is not real science. Neptune reflects approximately 41% of incoming sunlight, a moderately high albedo consistent with cloud cover in its upper atmosphere. This is explained by the composition of those clouds, methane ice crystals, and other volatile compounds that are efficient reflectors. There is no evidence and no physical mechanism proposed for a diamond-hard outer layer that reflects sunlight preferentially toward Earth. Neptune's albedo does not vary in ways consistent with a reflective shell. The planet's position relative to Earth varies on an orbital timescale, so any Earth-directed reflection would be seasonal at best. Neptune is strange and interesting and imperfectly understood. It does not need a sun mirror to be worth thinking about. The winds alone are sufficiently inexplicable. Story 26. N-rays, the radiation that only French scientists could see. N-rays were announced by the French physicist Prosper Ren Blondlot in 1903. Working at the University of Nancy, Blondlot claimed to have discovered a new form of radiation, distinct from X-rays, which had been discovered in 1895, that was emitted by most substances and that could enhance visual perception in dim light. N-rays were reportedly produced by compressed steel, by the human nervous system, and by many organic and inorganic materials. They could be stored in wood and discharged slowly. Their effects on vision were subtle, but measurable. Within a year of Blondlot's announcement, dozens of French scientists had confirmed the existence of N-rays through their own experiments. Papers flooded the French scientific journals. The phenomenon appeared reproducible, at least to French researchers working in French laboratories. Researchers from other countries attempting to replicate the findings were largely unable to do so, which was attributed to experimental incompetence or inferior French language ability. The demolition was performed by the American physicist Robert Wood, who visited Blondlot's laboratory in Nancy in 1904 and was invited to observe N-ray experiments. During one demonstration, in which the brightness of a spark was supposedly enhanced by the presence of N-rays, Wood surreptitiously removed the aluminum prism that was supposedly refracting the N-rays onto the detector. The experimenter continued to report the expected changes in brightness despite the absence of the prism. Wood published his account in Nature in September 1904. The N-ray literature rapidly ceased. The episode is a classic case of observer expectation bias, of experimenters perceiving what they expected rather than what was there. The French scientific community's investment in a French discovery may have contributed to the confirmation bias. N-rays were real to everyone who wanted them to be real, and to no one who didn't. Story 27. Fossil flood theory. The order in which everything drowned. The catastrophist flood theory of fossils, that the layering of fossil types in sedimentary rock represents not the sequence of evolutionary history, but the order in which organisms drowned during the biblical flood, was a serious scientific position in the early 19th century, held by some of the most distinguished naturalists of the period. John Woodward proposed in 1695 that the flood had dissolved all terrestrial matter, which then settled out of the universal ocean in order of specific gravity, producing the layered fossil record. Johann Jakob Scheuchzer believed he had found the skeleton of a human flood victim in Swiss limestone. The specimen was later identified by Georges Cuvier as the skeleton of a giant salamander. The theory had specific empirical problems from the beginning. The order of fossils in the rock does not follow the order of specific gravity. Complex organisms appear higher in the record than simple ones, which is not what settling from a universal flood would predict. Marine organisms appear throughout the sequence in ways inconsistent with a single flood event. The fossils of different geological periods were geographically separated in ways that required the flood to have sorted organisms by type and then move them to different continents. William Smith's stratigraphic work in the early 19th century demonstrated that specific fossil assemblages characterized specific rock layers consistently across England, allowing the rock layers to be mapped and correlated over long distances. This was incompatible with flood deposition. Cuvier's comparative anatomy established extinction, the existence of species in the fossil record with no living counterparts, which required either multiple creation events or the geological time the flood theory tried to compress. The flood theory of fossils is not compatible with the evidence. The evidence for deep time is overwhelming. The order in which things are preserved in the rock is the order in which they lived and died, not the order in which they drowned. Story 28. Emission theory of vision. The eyes that reached out and felt the world emission theory. The proposition that visual perception is caused by rays emanating from the eye rather than by light entering it was held by Plato, Euclid, Ptolemy, and many other major thinkers of the ancient world. The theory had an intuitive basis. Sight feels like reaching out toward an object, not like being passively struck by information from it. The eyes seem active, seeking, directed. The metaphors of vision in most languages emphasize the outward projection of attention rather than the passive reception of stimulation. Euclid developed a geometric theory of vision based on emission that correctly predicted many of the phenomena of perspective and apparent size. The theory has a specific empirical problem that was noted even in antiquity, but not always considered decisive. If vision works by rays projecting from the eye, why can't we see in the dark? Alhazen, the 11th century Arab physicist, made this argument central to his rejection of emission theory in his book of Optics. If the eye projects visual rays, darkness, the absence of ambient illumination should be irrelevant to vision. Since we cannot see in the dark, the eye must require external light to function, which means light is entering the eye rather than leaving it. Alhazen's intromission theory, that vision is caused by light from objects entering the eye, was correct. The intuition that supports emission theory, that vision feels like reaching out, is worth taking seriously as a phenomenological observation, even if it is wrong as physics. The eyes do not project light, but the visual system does construct its experience of the world through active processes, saccadic eye movements that scan the environment, predictive processing that generates expectations before input arrives, attentional mechanisms that prioritize certain spatial locations. The eye does not emit. The visual system does, in some functional sense, reach. Story 29, the shrinking earth. Mountains as wrinkles on a cooling apple. The contraction theory of the earth was, in the mid-19th century, the dominant scientific explanation for the formation of mountain ranges. Its logic was straightforward. The Earth had formed from a molten state and had been cooling ever since. As it cooled, the interior contracted. The outer crust, having already solidified, could not contract uniformly. Instead, it buckled and folded as the shrinking interior withdrew beneath it, producing the corrugated surface features we call mountain ranges. The analogy to the skin of a drying apple, wrinkled by the shrinkage of the fruit beneath it, was widely used and is a good intuitive model of the mechanism. The theory was developed by James Dana, supported by Lee de Beaumont, and taken seriously by most geologists until the late 19th century. It had a reasonable physical basis. The Earth has been cooling since its formation, and thermal contraction is a real physical process. The question was whether the cooling and contraction were sufficient in magnitude and the right geometry to produce the observed mountain ranges. The problems accumulated. The amount of contraction required to produce the observed shortening of the Earth's crust, as measured by the folding and faulting visible in mountain belts, exceeded what the physical properties of cooling rock could produce. The distribution of mountain ranges on the Earth's surface did not match the pattern that a uniformly cooling sphere would produce. The fossil evidence, by the late 19th century, was revealing that the continents had once been connected, a fact that contraction theory could not explain. Plate tectonics replaced contraction theory because it explained not just mountain building, but the full range of geological phenomena, earthquakes, volcanoes, the distribution of ocean basins, through a single unifying mechanism. The wrinkled apple was a good metaphor. It was pointing at the wrong physics. Story 30. Spontaneous generation of mice. The exact recipe that never worked. Jan Baptist van Helmont, the Flemish chemist who made genuine contributions to the understanding of gases and metabolism in the early 17th century, is also the author of one of the most specific and confidently stated recipes for the spontaneous generation of mice in the history of science. Place sweaty underwear, the sweat, van Helmont believed, contained the active principle, inside a jar with wheat husks. Leave for 21 days. A living mouse will be produced. Van Helmont believed he had observed this. He wrote it down with a specificity that distinguishes it from vague claims about mice appearing in stored grain. The specificity is striking in retrospect. The 21-day time frame, the requirement for sweaty underwear, the wheat husks as substrate. These details suggest something was being observed and systematized. What was being observed, of course, was that mice nest in grain stores, and that the population visible in a grain store after a few weeks is larger than the population visible when the grain was first stored. The mice were not generated. They were already there, where they arrived and bred. The underwear was irrelevant except insofar as it might have contributed a scent that attracted them. The experiment is easy to disprove, and was disproved, eventually, by Reddy's careful exclusion experiments and, definitively, by Pasteur's demonstration of biogenesis. The mice come from other mice. The wheat does not make them. What makes Van Helmont's recipe historically interesting is what it says about the relationship between observation and theory in pre-experimental science. He saw mice in his grain stores. He had a theory about where they came from. The theory organized his observations in a way that seemed consistent and productive. The experiment he described seemed to confirm the theory. The possibility that the mice were already there, that the theory was a lens distorting the observation, was not one that the conceptual framework of his time suggested he ask. Story 31. Blood personality transfusion. The patients who became their donors. The idea that blood carries personality. That transfusing blood from one organism to another would transfer not just physiological properties, but temperamental and behavioral characteristics, was part of the conceptual framework within which the first blood transfusion experiments were conducted in the 17th century. Jean-Baptiste Denis, who performed the first recorded human blood transfusion in 1667, transfused blood from a calf into a mentally ill patient, in the belief that the calm, gentle nature of the calf might be communicated to the patient along with the blood. The patient survived, which Denis counted as a success. A subsequent patient died, which Denis initially survived legally, but which led to the prohibition of blood transfusion in France and effectively ended the practice for over a century. The deaths from transfusion in this period were caused by immunological incompatibility. The ABO blood type system would not be discovered until 1901 and had nothing to do with personality transfer. The personality transfer claim was not supported by any observations that Denis or his contemporaries could document. The calmed patient was not reliably calmer after the transfusion by any controlled measure. The conceptual framework within which the experiment was conducted, humoral medicine, the idea that blood carried vital properties, made the expected outcome seem more plausible than it was. Modern blood transfusion science is based on the understanding that blood is a biological fluid containing cells, proteins, and molecules that perform specific physiological functions. It does not contain personality. Recipients of blood transfusions do not acquire the characteristics of their donors in any documented way. The idea that transfused blood might communicate something beyond its cellular components persists in popular culture, but has no evidential support. Story 32. The sympathetic powder, healing at a distance through the weapon that caused the wound. The weapon salve, or powder of sympathy, was a treatment for wounds that operated on the principle of treating the weapon that caused the wound rather than the wound itself. Apply the sympathetic powder to the sword that made the cut, and the cut would heal at any distance. The treatment was described by Paracelsus, was the subject of a treatise by Kenelm Digby in 1658 that circulated widely in learned circles and was taken seriously by some of the most educated people of the 17th century. Francis Bacon discussed it. William Harvey, who discovered the circulation of the blood, reported cases that he found difficult to explain through ordinary means. The mechanism proposed was analogous. There was a subtle connection between the blood on the weapon and the wound from which it came, and the healing action applied to one was transmitted through this connection to the other. The sympathetic powder, typically made from ingredients including vitriol and desiccated moss from a human skull, was applied with ceremonial attention to the weapon, kept clean and in a temperate environment, and was not to be altered or disturbed while the wound healed. The most convincing cases involved wounds that healed when the weapon was treated and worsened when the weapon was disturbed. These cases were genuine observations, but their explanation was not the sympathetic powder. Wound treatment in the 17th century frequently involved the application of substances, animal fat, various ointments, binding, that were more harmful than beneficial. Leaving the wound alone, which treating the weapon rather than the wound effectively required, allowed the body's own healing processes to operate. The weapon salve worked best when it prevented doctors from doing anything to the patient. The mechanism was wrong in exactly the most instructive way. The treatment worked for reasons it didn't understand. Story 33. Ontogeny recapitulates phylogeny. The embryos that didn't replay evolution. Ernst Haeckel's biogenetic law that ontogeny recapitulates phylogeny, that the development of an individual organism replays the evolutionary history of its species, was one of the most influential scientific ideas of the late 19th century and one of the most consequential errors in the history of evolutionary biology. Haeckel proposed in 1866 that as a human embryo develops from a fertilized egg, it passes through stages that resemble adult forms of ancestral organisms. It has gill slits like a fish, a tail like a reptile, and progressively takes on the characteristics of more recent ancestors before arriving at the human form. The theory was visually compelling. Haeckel produced illustrations of embryos at different stages of development that showed remarkable similarities between the embryos of different vertebrate species and that appeared to support the recapitulation idea. The illustrations were widely reproduced and became one of the most familiar images in biology education. The illustrations were not accurate. Haeckel modified them to emphasize similarities between embryos that were less pronounced in the actual specimens. This was discovered in his own lifetime and was a source of significant scientific criticism. The discovery was periodically re-reported in subsequent decades as if it were new, most notably in a 1997 paper that generated substantial press coverage, despite the fact that the inaccuracy of Haeckel's drawings had been known for a century. The underlying idea that embryonic development provides evidence of evolutionary history is not entirely wrong. Embryos do show features in development that reflect evolutionary ancestry. The pharyngeal arches that Haeckel called gill slits are real structures whose evolutionary derivation from ancestral gill structures is well supported. But the developmental sequence does not recapitulate the sequence of evolution in the way Haeckel proposed, and the ancestral adult forms are never actually present in embryonic development. Embryos resemble embryos of ancestral organisms, not the adult forms. Story 34, The Wandering Womb, the living organ that caused every female complaint hysteria, from the Greek hystera, meaning uterus, was a diagnosis applied to women for approximately 2,000 years and was attributed, in its original formulation, to the physical movement of the uterus through the body. Plato described the uterus as a living animal that desired to produce children and became troublesome when deprived of that function, migrating upward to occupy the chest, causing choking and suffocation, or descending to cause other disturbances. The treatment was olfactory, pleasant scents applied to the nose to draw the uterus back down, unpleasant scents applied to the vulva to repel it upward. Galen modified the theory without abandoning its uterine focus, attributing hysteria to the retention of corrupt menstrual blood or seed. The theory was not supported by anatomy. Dissection, available to physicians who undertook it, demonstrated that the uterus is firmly attached to the pelvic floor by ligaments and does not migrate. Physicians who dissected, and there were not many, and their findings were not always accepted by colleagues who had not dissected, knew this. The theory persisted despite anatomical evidence to the contrary because it organized a large body of clinical observation in a way that was culturally useful. It explained why women were susceptible to conditions men were not. It kept the explanation within the medical domain, and it provided rationales for treatments that patients and practitioners found meaningful. The diagnosis of hysteria survived the anatomical refutation of the wandering womb by centuries, simply shedding the physical mechanism while retaining the diagnostic category and its gendered application. What replaced the physical uterus as the mechanism was the nervous system, then the unconscious, then a series of diagnostic categories that successively refined and renamed the observation that people experience psychological distress in ways that produce physical symptoms. The wandering womb was wrong. The distress it was explaining was real. Story 35, Phlogisticated air, the poison breath that wasn't oxygen depletion. Before the chemistry of combustion and respiration was understood, the observation that enclosed spaces became deadly was attributed not to the depletion of a substance necessary for life, but to the accumulation of a toxic substance produced by living things. The phlogiston theory provided a natural framework for this interpretation. When animals breathed in an enclosed space, they were releasing phlogiston into the air, which became progressively more saturated with phlogiston until it could support neither combustion nor respiration. The theory was not unreasonable. Candles in sealed jars did extinguish as the air became unbreathable. Animals in sealed containers did die as the candles went out. The correlation between breathable air and combustion-supporting air was genuinely observed and genuinely required explanation. The phlogiston framework provided one. The problem is that the actual mechanism runs in exactly the opposite direction from what phlogiston theory predicts. Air does not become deadly because it accumulates something. It becomes deadly because it loses something, the oxygen that animals and flames both require. Joseph Priestley's discovery of oxygen in 1774 and Lavoisier's demonstration of its role in combustion and respiration provided the correct framework. What suffocates in a sealed room is the progressive removal of oxygen by combustion and respiration, replaced by carbon dioxide and nitrogen that support neither. The phlogisticated air theory also predicted that removing phlogiston from air should restore its life-supporting properties. Priestley's oxygen was initially described as dephlogisticated air, air from which phlogiston had been removed. In a sense, the theory got to the right answer through the wrong mechanism. The difference between breathable and unbreathable air was indeed a matter of phlogiston content, It just worked the other way round from what phlogiston theory assumed. The wrong theory predicted the right experiment and found the right result without knowing it.